Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 5 of Observability Zero to Hero series. Till now, we have completed 4 episodes in this series where using these 4 episodes, we have mastered the first pillar of observability, that is metrics. So we started with understanding the fundamentals of observability. Then we learned about metrics, monitoring, custom metrics, Prometheus, Prometheus query language. We learned about alerting, dashboards, everything practically in the first 4 episodes of this series. Now it's time to move towards the second pillar of observability, that is logging. So in this video, we will learn what is logging, why is it important in the world of distributed systems. Then we will understand about a popular logging stack, that is EFK stack. What are the different components? What is the architecture of EFK stack? How different components communicate with each other? And finally, we will also learn how to install, set up, and configure EFK stack on a Kubernetes cluster using Helm chart. So this video is going to be very interesting and informative as well. Make sure you watch it till the end. And after watching the video, if you are looking for the notes for this episode, you don't have to go anywhere. Just go to this GitHub repository. Link is in the description. Observability Zero to Hero. You can see already 2000 plus people have forked this repo. 1400 people have started the repository. It's very useful. Go to the Day-5 folder, and if you click on the README file, you can get the complete notes that I have explained in the series in this episode. You can see the architecture diagram, the commands that I'm going to use, and also the manifests that are used in the video. So you can use this particular repository for your revision purpose. Okay, now let's move to the whiteboard and start with understanding what exactly is logging and why is it very important. If I have to explain this in simple layman terminology, logs are nothing but messages that are written by the developers in the application or in the program to help end users understand what is the application doing at a particular point of time, so that you can debug the application, and if the application is not working as expected, it can tell you why is the application not working as expected. Let's take a simple example. Assume there is a developer, and this developer is asked to write a simple program, addition of two numbers. Now, if this developer just write the application without any log messages, for example, defines a variable and expects a command line argument, defines another variable, expects the second command line argument, then just says C is A plus B, and finally print C. Obviously, this is also a program that would work, but when it is given to a user who does not have any idea about this application, so user would execute this application, and what the user would see is a prompt that is expecting an input from the user. But the user would not understand if the prompt that is waiting for the user, is it expecting a string? Is it expecting an integer? Is it expecting a Boolean value? What exactly is it? And what is the program doing? So ideally, what developer should do is, instead of writing this way, developer should write a log message at the beginning of this program explaining, as soon as you execute, the program waits for two command line arguments or two numbers as input. Then obviously the program would be same. A is equals to first command line argument, B is equals to second command line argument. Now that the user has understood, user provides two numbers, the command line arguments are read, and C is equals to A plus B, finally print C, right? So with the log messages, the end users understand what exactly is the application doing, and if the application is not working, or there is some issue with the application, these log messages will help the end users debug the application, further understand what is the issue and why is the issue causing. A simple shell script without logging and with logging can clearly explain you. Like here, the shell script of addition of two numbers without any log messages would look something like this. Whereas with proper log messages, the shell script explains the person executing the program that, hey, starting with the addition process is complete and this is your output. So logs are important. This is a very simple application. Assume if the application has 10,000 lines of code and suddenly the application has stopped working. There is some issue with the application. How would you know at which point the application has failed? Did it fail at the 5,000 line? Did it break at the 6,000 line? And why did the application break? Is it issue with the index out of the bond? Is it issue with the exception that you did not handle? What is the issue? Why is the issue getting caused? So this is where logs come handy. You look at any applications today, the open source applications or applications that are written in your organization, you would find a lot of log messages. At every point or in every critical step of the application, you would see a log message, so that if that critical step is failing, this log message helps the end user understand that, hey, your critical step has failed and this could be the reason why the critical step has failed. Even if you have followed the first episode of this series where I was explaining about observability, I explained that there are three pillars of observability. First one is metrics, second one is logs, and third one is traces, where metrics explains what is the state of the system, and if something goes wrong with the system or application, logs will help you understand why the applications are failing, what is the reason why the application is failing. And finally, traces, which we are going to cover in the future classes, will help you understand how to fix the issue, right? So logs focus on why a particular issue is caused and how can you debug further, how can you troubleshoot further. Now the question is, but Abhishek, you were talking about EFK stack. So what exactly is it? Why do I need this thing? So if you take scenario where you have hundreds of applications or hundreds of microservices in your organization, and each of them are running in different places. If you take a Kubernetes cluster, you might have 10 applications in namespace 1, 10 applications in namespace 2, 10 applications in namespace 3. And imagine there is a scenario where there is a log4j issue, or there is issue with the database connection among some applications. How would you know amongst the 100 services that are running in different namespaces, which of these services has a database connection issue? Maybe a temporary database connection issue. Sometimes the issue is there and sometimes the database connection is established properly. But you are asked to troubleshoot this intermittent database connection issue. That is once in a while database connection issue. Now, if you have 100 plus services, how would you know in which service this database connection issue is there and in which service the database connection issue is not there? You can go to all of the 100 applications, go to the pod logs, and you can see in each of the pod log if, okay, this particular pod, does it have any issue in the logs? Second pod, third pod, you can go to 100 different pods. Otherwise, what you can do is you can create a centralized logging system where all the application logs, all the services logs are collected at one place. And at this place, you can execute a query either through the query language or through the user interface or through the CLI. But if you have a centralized logging system where all the logs are aggregated and you just search for DB connection message or connection timed out message or a particular error that you are looking for, and the query that you have executed or the error that you are looking for is searched amongst all the 100 services on this centralized logging system. It would be very beneficial, right? Because instead of going through 100 applications, each and every application in different namespace, you can go to this centralized logging system, which is the EFK system. You can go here and you can execute a query and get the required output that, okay, in service 1, service 10, service 15 and 40, there is a database connection timeout issue. And you can tell the developers that, okay, these are the 4 services that you have to work on because temporarily or intermittently I'm seeing DB issue on it. And whenever there are critical vulnerabilities, so you will have less time to react. The log4j issue or any vulnerability which are critical security issues, if you have such centralized logging systems, it would be easy to identify the vulnerable services very quickly and react immediately. Now, what are each component of EFK stack doing? Like, why do you have 3 different things? So to explain, EFK, where E is Elasticsearch and F stands for FluentBit and K stands for Kibana. If you have followed the monitoring classes, just like how you have Prometheus, where Prometheus has a time series database where all the metrics are stored in a particular format, and Prometheus uses exporters such as the node exporter or any other exporters, the database exporter, to retrieve the metrics from the applications, right? And there is a graphical representation or proper dashboards in the Grafana. So a user would come to Grafana, look for a dashboard, execute a query. So the query is executed on the time series database of Prometheus, where these exporters are storing the metrics taken from the application in the time series database. Similarly, exactly like the metrics architecture. Here you have different applications, right? Let's say you have three different applications which are deployed on the Kubernetes cluster. There is something called as FluentBit. Let me just write it as FB. FluentBit, which is deployed as a daemon set, exactly like your exporters, the node exporter or any other exporter in the world of metrics. Here you have FluentBit, which is deployed as daemon set. What does a daemon set do? It is deployed on each node of the Kubernetes cluster, and this FluentBit reads the logs from the pods of the Kubernetes cluster at a particular location and forwards these logs. So it forwards the logs to Elasticsearch, which itself is a database. So the logs are stored in the Elasticsearch. You can attach Elasticsearch to things like EBS volumes so that you can take a backup of logs on the timely basis. You can create snapshots. And then there is a visualization dashboard such as Grafana, which is Kibana. So if you have followed the metrics, it would be very, very simple to understand this architecture. That's why I told you at the beginning of the video, if you have followed metrics, logging is very, very simple because kind of the architecture is the same. Now you might feel there is Elasticsearch, there is FluentBit, there is Kibana. Why there are so many components? It is very confusing. But if you understand this flow, what is FluentBit doing, what is Elasticsearch doing, and what is Kibana doing, it is very, very simple. Let me repeat this one more time because this is the core part. This is the very important part of logging. So even if people ask you an interview, what you can explain is in the EFK stack or in the FEK stack, because it is also called as FEK stack. The first component that you have is FluentBit, where FluentBit reads the log messages from the nodes of the Kubernetes cluster. It is a daemon set deployed on every node of the Kubernetes cluster. We are going to see this configuration practically as well. Don't worry. So from every node, different FluentBit instances takes the log messages and forwards these log messages to Elasticsearch, which itself has a database, and Elasticsearch keeps all the log messages. Now, logs are quite heavy, right? Because your application omits thousands of logs. And if you have hundreds of such applications, so the database will become very huge. So it can go up to GBs every day. In classic banking applications or in classic financial applications where you have multiple services, each day your Elasticsearch, the database, can even get some GBs of logs, maybe 1 GB, 2 GB, 3 GB of logs. So it is better to create Elasticsearch as a persistent volume and connect it to maybe the EBS volumes, and every day you can take snapshot of these EBS volumes. And because it's a database, sometimes it is difficult to query. Of course, you have the query language. You can query the Elasticsearch directly, but to make it easy for the end users and for better visualization experience, just like what Grafana does for you, you have something called as Kibana. So end users can use the Kibana UI, can execute or fire some queries, which are basically getting out some values from the Elasticsearch and giving that back to the user on the Kibana dashboard. FluentBit is doing the underlying job of collecting the logs. It can collect different kinds of logs from different input sources and forward that to the Elasticsearch. So the architecture is clear now, right? I know many of you at this point have a question that Abhishek, why EFK stack and why not ELK stack? You could have explained ELK stack in the series. Why did you go for EFK stack? Unfortunately, a lot of people don't realize that EFK stack is more than enough for them. So in this case, ELK stack is Elasticsearch, Logstash, and Kibana. So if you observe, Elasticsearch is common, Kibana is common. Only difference is that FluentBit versus Logstash. In again simple words in layman terminology, Logstash has more rich features when compared to FluentBit. FluentBit is just a log forwarder, whereas Logstash is log aggregator. So, along with collecting the logs, just like how FluentBit collects logs from every node, but FluentBit will directly forward the logs to the Elasticsearch. Whereas with Logstack, you can filter out the logs. Of course, you can do that with FluentBit as well, but only to some extent. With Logstash, you can do advanced filtering, you can do advanced labeling, you can perform some more actions at the Logstash before they are forwarded to the Elasticsearch. But many organizations don't need it. So if the if FluentBit is forwarding the logs to Elasticsearch and proper backup of Elasticsearch is taken, FluentBit is more than enough. And this is very lightweight when compared to Logstash. And the chance of issues with FluentBit is also very, very less when compared to Logstash. In future classes, when we do projects on ELK stack or projects on observability, I would cover Logstash as well. But right now, if you are starting, start with FluentBit because it is very simple, very lightweight, and it does its job by just forwarding the logs to the Elasticsearch. Okay, now can we proceed with deploying the EFK stack? Yes, let's do that. So let's take our Kubernetes cluster. So this is my Kubernetes cluster. I have the cluster created already. You can use the same cluster that you have created in your previous classes as well. If you are following the series and if you already have a cluster, that's perfect. You can use that. All that I need is a Kubernetes cluster that is set up with the nodes. And if you go to the README file, you will find the first thing that you have to create is create a IAM role for service account. Why is this needed? Because as I've explained, first you will have the FluentBit, which is forwarding the logs to Elasticsearch, but we will use Elasticsearch as a stateful set and we will mount it with EBS. Now I'm using EKS cluster. This is a very important concept. People fail to understand this and mostly these are asked in the interviews. Like my Elasticsearch is on the Kubernetes cluster, whereas EBS is outside the EKS cluster. Of course, both of them, both the Elasticsearch and the EBS volumes are in the AWS environment, but one is in the EKS and other is EBS. So the volumes are EBS volumes and Elasticsearch is in EKS. Now, how can the EKS cluster, the Elasticsearch in the EKS cluster communicate with the EBS volume? So what you would do here is you would map the service account of the Elasticsearch with a IAM role, right? So we will use an IAM role where the Kubernetes service account of Elasticsearch is mapped to the IAM role, where this IAM role can create a EBS volume or can talk to the EBS volume. So this cannot be done directly. For this, the another step that we are going to do is we are going to use a CSI driver for EBS. This CSI driver will create the EBS volume, and the storage class and persistent volume claim are created accordingly. So let's start with creating the service account. I will go back to my cluster, and here the name of the cluster that I'm using is Observability 1. In your case, you don't have to change it. I have another cluster where I'm doing the tracing part. So that's why I'm just for the separation using the cluster name as Observability 1. Okay. So the IAM service account is getting created. So this will be the service account that we will use in the Elasticsearch. And next one is to, once the command execution is complete, we will retrieve the IAM role name. Okay, so the IAM service account is created. Now let's retrieve the role name. Okay, we got the role name. I stored it in the ARN, the variable called ARN. Now it is time to deploy the CSI driver. I told you why CSI driver is required. It is required because in the EKS, when you use the persistent volume claim, and if the storage type is EBS volume, you need a driver that can create the EBS volume for you. So this is where CSI driver comes into picture. So again, I have to change the cluster name to Observability 1. You don't have to change it. So, okay, the add-on is getting created. The CSI driver is done. Now let's create a namespace called logging. Why is this required? We are going to deploy our EFK or FX stack onto this namespace. Cool. Let's deploy component by component. Let's start with Elasticsearch. First, I need to add the Elasticsearch repo. Okay, it says it's already there. Good. Then let's run helm install Elasticsearch. And here the volume claim type. In the Helm chart, I am passing an argument where the volume claim type is of storage class GP2, which is for EBS. Perfect. Now the Elasticsearch would be installed. We need to retrieve the username and password for Elasticsearch, because when your log forwarder, that is the FluentBit, when it wants to forward the logs to Elasticsearch, as I've explained here. So if the FluentBit has to forward the logs to Elasticsearch, it would need authentication, right? Because it is pushing the logs. So you need to take the username and password of Elasticsearch, which we are just creating. And when we deploy the FluentBit, we will pass that username and password in the FluentBit configuration, so that FluentBit can talk to the Elasticsearch. Cool. Elasticsearch is created. So let's get the username. I think the username is Elastic. Perfect. And let's also get the password. As soon as you get it, keep them handy, because when we are going to install FluentBit, we are going to pass that. And let's install Kibana as well. It's easy. So for Kibana, I'm doing the service type as load balancer type, because I want to use and access Kibana from the user interface. And once Kibana is also installed, what we will do is proceed with the FluentBit. So the repo is already added in my case. I'll not do it. But this is the command for installation. Before that, we have a values.yaml file in the Day-5 folder. You need to update the values.yaml, right? So don't confuse looking at the length of the FluentBit configuration file, the helm values.yaml. You will not change most of the things here. You would only change couple of things, which I'm going to explain. Okay, this is also done, Kibana installation. Now, if you go back, so this is the command for installation of FluentBit. But before executing that, let me clear the screen. So before executing it, you need to update the values.yaml. So what we will do is, sorry, I forgot to save the Elasticsearch credentials. So this is the password. Now I will copy the password and vim fluentbit.yaml file. Just search for http, not this. So you have http user and http password. So go to the http password and just change the password. Similarly, in the next section as well, there are two output sections. Uh, in the FluentBit, what is output section? I will cover in a while. Basically, it is outputting the logs or forwarding the logs to Elasticsearch master, which is the stateful set. So just make sure the password is provided here as well. Cool. So save this file and just run the Helm install command. Before that, you need to add the Helm repo as well, but in my case, I already have it. Okay, it says there is some issue at the line number 449, probably the indentation issue that might have created. 449. Yep. So there is an indentation issue here. Let me just remove these. That is not required. Perfect. So FluentBit installation will also be done. And once this is done, cool. So this is also done. What we will do is, let me take another tab. Just check kubectl get pods in the logging namespace. Do I have Elasticsearch running? Yes. It's a 2-node Kubernetes cluster. That's why we have 2 pods of FluentBit, right? That is the concept of daemon set. N number of nodes that you have, you will see n number of replicas of the pod, each replica running on one node, because it has to fetch details from the node. So we are running FluentBit as daemon set. Kibana is also running. And when you do kubectl get svc logging, you can see Kibana, I have created the load balancer service type. So just copy it. Take browser, use port 5601. Everything is explained in the notes as well, so you don't have to worry. And here the username would be Elastic and password would be the same, the one that we have retrieved. Let me retrieve that again. The base 64 encoded. Yep. So now you have the Kibana dashboard. Okay. So this Kibana dashboard is automatically connected to Elastic, and your log stash is forwarding the logs. So right now you will not see any logs here, and there would not be any integration because we don't have any applications on our Kubernetes cluster, right? If you go here and click on the discover, you will see that, okay, you have data in Elasticsearch, created data, because the data is coming from other namespaces, other pods, but I don't have application created for myself. So what we can do is we can deploy some application to test if the logs of that application are seen in the Elasticsearch. Is FluentBit forwarding the logs to Elasticsearch, and can we see that on Kibana or not? What we can simply do is go to the day 4 folder where I have an application. So just go to service A, and or let's go to the readme file where I have provided the steps of installation of this application. So we will just create a namespace called dev, switch to day 4, or you can install any other application, pick up an open source application and you can also install it. That's up to you. So let's create a namespace called dev, and within this namespace, let me just apply the manifest. Okay, service A is created, service B is created. Now I just have to wait for kubectl get pods in the dev namespace. They are still creating. Cool. So the pods are created, and if I just log a particular pod, kubectl logs, let me just get the logs of it in the dev namespace. So there is a simple log. I just said service A is running on port 3001. Cool. So now the logs are there. If you use kubectl get pods in the logging namespace, and I want to see if FluentBit, any replica of the FluentBit, was able to understand that service A is created, and is it able to pull the logs of service A or not. So kubectl logs, let's look at this FluentBit instance. And if I do the logs, okay, so initially you might see this warning message where it is saying fail to flush, but you can see here that it has identified the service B. So service B deployment. And if you scroll up, you can also see a message for service A. So ignore this warning message. Whatever it is saying, fail to flush the chunk. It is not an error message. It's a warning message. You can also get rid of it, but for now that's okay. All that I want to show you is there is an info message in the FluentBit saying that it could find service B deployment and service A deployment. And it has forwarded that to the Elasticsearch. So now in Kibana, create a view. Let's call it as log management. And you can also provide a log pattern. For now, let me just say it as so you have two log patterns already here. So you can select one log pattern and save data view for Kibana. As soon as you do it, see, you can see the logs that are already recorded. So you have logs coming from different namespaces. You have logs coming from your application that is created for you. And you can also see the timestamps, right? So how is Kibana getting this? From Elasticsearch. How is Elasticsearch getting it? From FluentBit. You also have, just like Prometheus query language, you also have something called as Kibana query language, using which you can filter out a particular log message. Like some of them are coming from kubeproxy, right? So if you want to get rid of kubeproxy namespace and you only want to see the namespace called dev, you can do that from the Kibana query language. So I mean, right now I'm not focusing on the Kibana query language because it itself will take a complete class. The focus is to explain you the setup of the FEC stack and explain how the log forwarding is done and how the components talk to each other. And one thing that you should focus is on the FluentBit configuration. Another advantage of FluentBit is that it is vendor neutral. Tomorrow, if you want to move from, let's say, Elasticsearch to Splunk or to any other log management platforms, FluentBit can work as is. Whereas if you are using Logstash, you can restrict to a particular platform, and that would become a bottleneck for you. So in FluentBit, make sure you go through this FluentBit configuration file. So there are 4 primary things in FluentBit configuration: the service, input, output, and filters. So service is basically for the service configuration, like you want to expose the FluentBit in node port mode, cluster IP mode, or you want to add enable any particular feature of FluentBit. Then you have input. Where is the input coming from? In our case, the input is coming from the container logs. So if I just search input here, so you can see the input is coming from var log all the containers. So start.log. So typically all the container logs are taken as input. That is where we are reading from the pod logs. And you have the filter section where you can filter out, let's say in this case, if you go to the Kibana, you will not find any logs from the logging namespace. Where I have installed Elasticsearch, Kibana, and FluentBit, I have omitted or ignored that particular namespace. You can see that in the FluentBit configuration. If you go to the configuration file and if you look at the filters, you can see I have used a Lua script file. Of course, this will take time for you. It would need some experience as you keep using FluentBit. This is the very first class. So you might find the Lua script overwhelming, but in the Lua script, you can do the filter outs where you can say, ignore a particular namespace. In this case, I have ignored the logging namespace. Similarly, you can ignore the kube system namespace or the any Kubernetes API related components. And finally, you have the output section where we have updated the password. So in the output section, you will define where the FluentBit has to forward the logs. In our case, we said it is Elasticsearch. The host name or the service name is Elasticsearch. Port is 9200. And this is the username and the password. If you are running this on AWS cluster, EKS AWS cluster, make sure the TLS is on. Otherwise, the connection will not establish. Perfect. So this is the output section and this is the output configuration. So you can go through the FluentBit documentation. It would take probably 1-2 days to master the FluentBit configuration. And if we get time, maybe after this observability series, I would make a detailed video, as I told you, on Logstash, similarly on the FluentBit as well. Perfect. So make sure you practice this. and make sure you have your Kibana setup with different applications and you see the logs for it.